So welcome to the video. Today we're going to take a look at how to do a between participants one-way analysis of covariance, or ANCOVA, using SPSS version 29. We'll also take a look at the assumptions of this test and how to check those and how to report those. And of course, we'll take a look at how to interpret and report the results of the ANCOVA itself. So we're going to use a between participants one-way ANCOVA when we have a categorical between participants variable or between subjects variable, and when we have a continuous dependent variable and one or more continuous covariates. So for this example, let's imagine that we have treatment as our independent variable. So we have treatment 1 and we have treatment 2. Our dependent variable is going to be symptom severity post-treatment, and our covariate is going to be symptom severity pre-treatment. So basically we're asking, is there a difference in the effectiveness of these treatments while controlling for the level of symptom severity before the participants had the treatment? So let's take a look at how to put these data into SPSS. So we'll go to SPSS and we'll go down to variable view and click this tab, and this will open this different screen. And then we'll go up to the top here and we'll enter the name of the independent variable. So I'm going to call that treatment. Then we will enter the name of the covariates. So I'm going to call this severity pre. And then I'll enter the name of the dependent variable. So I'm going to call this severity underscore post. So I'm using underscores there because SPSS doesn't allow spaces in certain places. So then I'll use this measures column to specify what types of variables these are. So we have a nominal independent variable. So nominal is just another word for categorical. And we have a continuous dependent variable and a continuous covariate. So this is the covariate and this is the dependent variable. So scale is just another word for continuous. Then we can go to this values column and the treatment row and just click on the cell here. And we'll click on this gray box. And this allows us to tell SPSS what the levels of the independent variable are. So if we enter a 1 here, then we can enter treatments A into this label box. We'll click add and then we'll put a 2 here, and then we'll write treatments B in the label box next to 2. And then we go to OK. And then if we go down to data view, we can see that the names of these variables have appeared above these columns. And then we can just copy and paste the data from the Excel file. So I'm just going to copy all of this by pressing Command C or Control C. And then I'll click the top cell in the leftmost column, and then I'll press Command C or Control C to paste that data in. And we can see that we have treatment A and treatment B in this column, whereas in the Excel file we just had 1 and 2, and that's because we've already told SPSS that 1 equals treatment A and 2 equals treatment B. And that's because if we go to this view menu, we can see that value labels is selected. If I untick that, those words are replaced by the original numbers. So I prefer to keep this ticked. So there are quite a few assumptions of the ANCOVA. One is that the dependent variable is normally distributed within each group. Another is that there is a linear relationship between the dependent variable and the covariates within each group. That there is homogeneity of regression slopes, and that there is homogeneity of variance. So we can check this fourth one as part of the procedure for running the ANCOVA, but we need to check these other 3 before we run the ANCOVA. So the first one we can check is the dependent variable is normally distributed within each group. So to do this, we can go to Analyze, then down to Descriptive Statistics, then across to Explore, and then we can transfer our independent variable to the factor list and our dependent variable to the dependent list. Then we go to Plots. I'm going to untick stem and leaf, and I will tick normality plots with tests. Then I will go to continue and then to OK. So we can see in this table here that we have two tests actually run to check normality. So there's one here and there's another test here. Normally, if you have fewer than 50 participants, you're going to use the Shapiro-Wilk test rather than this test here. So in this case, I have 10 participants in each group, so I have 20 participants in total. So I'm going to stick with this Shapiro-Wilk test here. And the most interesting thing is the value in the sig column. What we want to see is that the value is above 0.05. So we have that in both cases. We have 0.287 and 0.191. So both of those values are above 0.05, which indicates that the data are normally distributed in both treatment A and in treatment B. So we've checked that assumption and that's been met. So let's move on to checking the next two assumptions. So we can check these sort of both at the same time really by creating a scatter plot that represents the relationship between the dependent variable and the covariates. So to do this, we can go to graphs and then down to scatter/dot, and then we're going to select simple scatter and then define. I'm going to move the dependent variable to the y-axis box, the covariate to the x-axis box, and the independent variable to the set markers by box. And then I will go to OK. I'm just going to double click on the scatter plot that we just created to open the chart editor. And at the top here, there's an option, add fit line, add subgroups. So I'm just going to hit that. And that adds these lines of best fits. Basically, we want to see that there is a linear relationship between the covariate and the dependent variable within each level of the independent variable. So essentially, we want to see that the data points can be represented well with a straight line. Arguably, that's what we see in this case. So as the pre-treatment severity scores go up, so do the post-severity scores, and that's sort of represented by the straight line. This is a very small data set, so the scatter plots never look very good when you have so little data, but hopefully this sort of demonstrates the type of thing you should see. So we can conclude on the basis of that scatter plot that there is a linear relationship between the dependent variable and covariates within each group. And we can also use the scatter plot to get an idea about this assumption too. So there is homogeneity of regression slopes. So essentially those lines we just created represent regression slopes. And homogeneity of regression slopes means that those lines are essentially parallel, or they're close to parallel. And we can see that these lines pretty much follow the same sort of angle upwards. So we could conclude on the basis of this that also this third assumption has been met. But there is a way of testing this statistically as well. So I'm going to go up to Analyze and then down to General Linear Model, then across to Univariate. I'm going to transfer the independent variable to the fixed factors box, the dependent variable to the dependent variable box, and the covariate to the covariates box. I will then go to Model, and I'll select Build Custom Terms. And basically we need to get these over here. And you have to do this sort of indirectly. So we'll select the independent variable, we have to move it down here, and then we click Add, and it appears up here. And then we'll do the same thing with the covariate. Move it down here, select it, press this arrow, comes down here, then we click Add, it appears over here. And then finally we want to have something over here that represents an interaction between the two. So to do this, we select treatment again, we move it down, but this time we click By, and then we select the covariates and we move this down. So we have both of these down here, and then we click Add. So we have that up here. So once it looks like this, we can go to Continue and then to OK. And what we are most interested in is this row here. So it's the row that represents the interaction between your independent variable and your covariates. And we want to see that there is a non-significant value in the sig column. So it's essentially telling us that there's not a significant difference in the angles of those lines that we looked at within the scatter plot. So we can conclude on the basis of this as well that the assumption of homogeneity of regression slopes has been met, because this value here is above 0.05, indicating that there isn't a significant difference in the angles of those two slopes. So those are the three assumptions that we can check beforehand, and we're just left with this homogeneity or variance assumption, which we can check as part of the ANCOVA itself. So to run the ANCOVA, it's actually the same process that we just completed. So it's analyze down to general linear model, then across to univariate. And we can see that we still have these things in the appropriate places, but we just need to sort of reset this. So we'll go back to full factorial and then continue. And there's a few other things we can check while we have this univariate window open. So let's go to options and let's take descriptive statistics, estimates of effect size, and homogeneity tests, and then continue. And then let's create a plot at the same time. So we'll click plots and we can transfer treatment to the horizontal axis, and then we can click add. You can choose whether you want a line chart or a bar chart. I would go for a bar chart, and you can choose whether you want error bars. So if we tick this, we'll get error bars, and the default option is 95% confidence intervals. So I'm just going to click continue and then OK, and that's going to run the ANCOVA for us. So to check the assumption of homogeneity or variance, we can go to this Levene's test of equality of error variances table, and what we want to see is that the value in the sig column is below 0.05. Sorry, we want to see that it's above 0.05, but actually what we have is that it's below 0.05. So this indicates that there was a slight violation of this assumption of homogeneity of variance. What we can do if we see this is just adopt a more stringent alpha when interpreting the results of the ANCOVA. So usually, of course, when we're looking at the results, we're looking to see whether our p-values are above or below 0.05. But if we're adopting a more stringent alpha, we could use something like 0.01 instead. We can decide whether something is significant or not on the basis of whether the p-value is above or below 0.01 instead of 0.05. So let's take a look at the results of the ANCOVA itself. So I'm going to go to this test of between subjects effects table, and I'm going to focus on this treatments row, and we can see that we have a p-value that's less than 0.001, so it's far less than 0.01. So this indicates that there's a significant effect of the independent variable on the dependent variable while controlling for the covariance. So let's take a look at how to report these results. Basically, we can start off just by saying what we did. So a one-way analysis of covariance was run to examine whether post-treatment symptom severity scores differed between the treatment A and treatment B groups while controlling for pre-treatment symptom severity scores. And then we can mention all of the tests that we did to check the assumptions. So preliminary checks were completed to assess the assumptions of normality, linearity, homogeneity of regression slopes, and homogeneity of variance. And then we can get on to reporting the actual results of those assumption checks. So we have here a sentence that refers to the normality assumption. So a Shapiro-Wilk test indicated that the post-treatment symptom severity scores were normally distributed in the treatment A group and treatment B group. So let's just take a quick look at where those statistics that are also mentioned in the sentence come from. So if we scroll back up towards the top of this output, we can find this test of normality table, and we can see here that I've reported treatment A is this row here, and then W equals 0.91. So that's coming from this statistic column, just rounded to 2 decimal places. We have a degrees of freedom value here. So this DF represents degrees of freedom, and that's 10. That's what we have in parentheses here. And then we have P equals 0.287, and that's what we have in the sig column here. And basically the same thing. We've got these statistics here for treatment B from the row below. So then we've just mentioned that we created a scatter plot, and this indicated that the relationship between the pre and post-treatment symptom severity scores was linear in both treatment groups. At this point, you could include a reference to a figure, so you could have something like this, and then you would have the scatter plot somewhere nearby, or you could include it as an appendix, so you would have something like this. So whichever works for you. So we've mentioned here that we have a scatter plot that suggested that the regression slopes were similar, but we've also referred to the fact that we completed a statistical test to check this assumption as well. So we've got the results of that test here. And so those come from this test of between subjects effects table. And we're looking at this row that represents the interaction between the independent variable and the covariance. So we have f equals 0.08, and that's what we have here, just rounded. It's what we have here, just rounded to 2 decimal places. And then we have these degrees of freedom in brackets. So we've got the 1 is coming from this df column in this same row, but then we're taking the error degrees of freedom, which is 16, and we're putting that here. And then we've got p equals 0.77, and that's just the sig value here. So that's that assumption reported. Next, we're looking at this assumption of homogeneity of variance. So we've said that Levene's test indicated that the assumption of homogeneity of variance was violated. And that comes from having looked at this Levene's test of equality of area variances table. So that indicates that the f value is 4.71, so that's just coming from here, rounded to 2 decimal places. And then we have 2 degrees of freedom values to report, 1 and 18. Those are in parentheses here. And then we have the sig value 0.044, which is what we have here, p equals 0.044. And then I've just mentioned that we used a more stringent alpha of 0.01 to account for the fact that there was a violation of this assumption. So finally, we can get to the results of the ANCOVA itself. So we've said after controlling for pre-treatment symptom severity scores, post-treatment symptom severity scores were significantly higher in the treatment B group compared to the treatment A group. So I'm just getting those means from this table here. So this is one of the boxes we ticked. When running the ANCOVA, we requested that we would like some descriptive statistics. So we've got 7.2 here for the mean in the treatment B group. So that comes from here, and then the standard deviation 1.03 comes from here, and the same thing for treatment A. Here's the mean, here's the standard deviation, and that's what we've reported here. So let's go down to this test of between subjects effects table, and here we are saying f equals 191.33, and we are getting that from this treatment row. So that's my independent variable, and the f value is here, 191.326, which is this, rounded to 2 decimal places. Then we have the p-value is less than 0.001, that's coming from the same row and in the sig column. And then finally we have this partial eta squared value, which is 0.92, which we're getting over here. We're just rounding it to 2 decimal places. If you're interested in how to format the graph as well, we'll just take a quick look at how to do that. You probably don't want these bright blue fat bars in your report. So let's double click on this chart to open the chart editor. We can then double click on the bars. We can go to the bar options tab in this properties menu, this properties window that opens. And then we can use this thing here, just slide it across to the left, and that'll create some skinnier bars for us if we click apply. And we can also go left a bit here and check out this fill and border tab to change the color. So let's pick a gray color and click apply. We can also just delete anything we don't want. So certain things you probably want to add yourself within your Word file rather than have them be a fixed part of the figure. So I will just click on a few things, and then if you just click backspace, that should just remove anything you don't want. You can also just edit anything, any sort of written content. If you click on it once, then you click on it again, and that allows you to edit what it says. So we could change this to something like symptom severity. And lastly, if you just click on any bit of writing, you can double click on it, it'll open this properties menu, and then you can change things like the font style. So maybe you want to use the same font that you're using in your report, and you can change the size as well, because at the moment this looks quite small, so that would be quite hard to read. So let's just choose a larger font, click apply, and we can see that that looks a bit easier to read now. And any changes you make here will be saved automatically. So just press this red button when you're ready. That will close that, and you can see that the changes you made have been saved in your output file. So that's essentially it. If you have any questions, let me know in the comments, and I will try to get back to you. Thanks for watching. See you next time.